In the CASCADE project, we aimed to design an adaptive bridge that would increase communication and cooperation at sea. The project involved 7 partners from 5 European countries. We worked with 2 types of adaptation: automatic adaptation, where the ship bridge adjusts itself to the environment, and manual adaptation, where it is down to the user to configure how information is displayed.
A central theme on the project was learning from the direct experience of seafarers, starting with an onboard visit to explore where it would be most effective to focus the research.
We want to improve how the mariners are interacting with their electronic systems here on the bridge. We have to understand how they interact, and the next step would then be to identify problems, to discuss with them ideas how to improve the systems.
Focus groups were conducted with seafarers which identified communication and cooperation as key areas for improvement on the bridge.
We're here visiting the control room in the simulator suite at Warsash Maritime College, watching some cadets being put through training scenarios involving a pilot boarding the ship and them avoiding certain traffic. During this 2-day visit, we've also been interacting with various focus groups, asking them about team behaviour on the bridge. We've also shown them some very early design ideas for new tools.
Using a ship simulator, we ran scenarios to explore how seafarers interact.
We are here at the demo system from Raytheon Anschutz. We have difficult situations that seafarers face. For example, we have a master-pilot exchange where a lot of communication is necessary. And at the end, we will see how our devices and ideas from CASCADE will enhance solving the situation.
The physical simulator was complemented by a virtual simulation platform that modeled seafarers' movement on the bridge and extended the range of scenarios that could be explored. By simulating human-machine interaction, it was possible to test bridge designs at new and very early design stages and optimize the information exchange between seafarers and bridge equipment. In this way, CASCADE supports a shift from sensor-based information presentation and bridge design to a more human-centered and context-aware adaptive approach.
A mock-up console produced halfway through the project was used to evaluate the relative merits of 3 different console configurations. Actors were hired to demonstrate how the different configurations would look in use, with green screen technology used to make the demonstration videos as realistic as possible. An online survey was conducted to gather feedback from seafarers on the 3 configurations, with the central console chosen as the optimal position for a new shared display. The touchscreen shared display was designed to aid communication and cooperation on the bridge.
A key feature was customization. It is central to all consoles, in particular the shared display, which allows one screen to show multiple sources of information in whatever configuration is best for a particular situation. Focus groups in the second cycle of the project helped design pre-configured modes. 3 key applications for the shared display were annotation, notepad and checklists. Annotation allows the crew to draw on screens and communicate in a visual way. In a stressful environment where English is a second language for many, having the ability to convey intentions visually can prevent miscommunication. The shared display has a notepad feature allowing notes from one watch to be passed on to the next. The original idea for this information tool came from seafarers in our early focus groups. The shared display contains electronic checklists, which can be completed by different crew members and saved.
Physical aspects of the bridge console were also improved. The new CASCADE console was made height adjustable to accommodate the different heights of crew members and to allow operation in a sitting or standing position. This contributes to the manual adaptation of the bridge. Displays on the console can be tilted to the liking of the users, for example to minimize light reflections. The shared display is placed in the middle section of the bridge to allow cooperative operation by 2 crew members sitting or standing on the left and right sides.
Finally, the CASCADE console was integrated with tools used by pilots in their PPUs, or portable pilot units. CASCADE developed a protocol to share pilotage routes between the PPU and the ship's electronic charts, to allow crew members to see extra information normally only available to the pilot.
At the end of the project, the console was evaluated, once again bringing in seafarers using their expertise to critically assess the final prototype.
Better communication between the guys on the bridge, between the pilot and the captain to have a whole new level. I mean, it's the modern way. You know, everybody is now having tablets and everybody get used to it, and it's even more to share the information. I think it's a good tool.
Through innovative research techniques such as modeling and simulation, listening to the experience of seafarers, cross-discipline collaboration and forward-thinking ideas, CASCADE produced a new concept in bridge console design. By improving communication and cooperation and providing adaptive features on the bridge, CASCADE has contributed towards the prevention of accidents and the improvement of efficiency on board, impacts that will be felt by both individual seafarers and society as a whole.